Okay, so that was our warm-up. We have some new vocabulary. Perpendicular lines. You have that they form to make 90-degree angle, so 90-degree right angle. Also, the slope of one is the negative reciprocal of the other, and that'll come in later when we're dealing with slopes, but that's part of the definition. So I want you to have it now so it's not completely from left field later. And they, intersect at 90-degree angle like that. The symbol for perpendicular is two perpendicular lines or an upside down capital T. So if you make this symbol, you don't have to write the word perpendicular. That's what that symbol means. And then we have the perpendicular bisector, which is any line, segment, ray, or plane that is perpendicular to a segment. It has to be a segment because it has to have length. And then it cuts it in half. So you have some line coming through, and you have some segment. It gets cut in half, and it's perpendicular. Okay. Then we have some theorems that says through any given point on a line, there is exactly one line in the plane. It has to be in the same plane that is perpendicular to that line. So if I have a line, pretend that's straight, it has to be straight to be a line, and I have a point on that line, okay? There is only one line that can go through this point and be perpendicular. Any other line that I would try to draw would not be at a 90-degree angle. Our other one is that if two lines are perpendicular, then they form congruent adjacent angles. Remember, adjacent angles are touching each other, sharing a wall? Well, if I have perpendicular lines, and they're adjacent angles, but this is a line, so it adds up to 180. Well, if this is 90, then that means the other one is also 90. So they're congruent. So if this is angle 1 and this is angle 2, they're both going to be 90. And if two lines form congruent adjacent angles, so if I come in here and I have two lines and I have angle 1 and angle 2, and I know that angle 1 is congruent to angle 2, then that has to mean that the measure of angle 1 and the measure of angle 2 is 90. So it kind of goes both directions. If you have two lines and they're perpendicular, then they form congruent adjacent angles, which are 90. If you have congruent adjacent angles, but you don't know what their measure are, but if they're adjacent angles and they're congruent, then they have to be perpendicular, because they're two lines that are intersecting. And then the last one is only one perpendicular can be drawn from a point to a line. So this one's kind of like number 6, where number 6, the point was on the line that said only one line can be perpendicular through that point. Well, if I have a line and I have some random point out in space, just anywhere not on the line, there's only one line that can go through this point and be perpendicular to that other line. Again, because if I draw any other line through this point, it will not intersect at a 90-degree angle. There's only one straight 90-degree angle line. Here's our picture, our example, okay? What we have is that means that they have to be right angles. This is our picture better drawn than the ones I was drawing underneath. Okay? So a segment AC is perpendicular to the segment DB. We can use this symbol for the word perpendicular. And you don't ever have to write the word out or write the complete sentence. I know if you write it out in words, you have to write all of this. If you write in symbols, that means the same thing as that whole line did. So if AD is congruent to DC, then it has to be the perpendicular bisector. So if this length is the same as this length, that makes a perpendicular bisector. If those two are not the same length, well, we still have that the angles are congruent and we're perpendicular. We just aren't a bisector. We use these facts, the bisecting and the perpendicular angles. Okay, so we want to find angle X. Okay, we know that because this is perpendicular, that makes this 90 as well. And so we can take 90 minus 37 to find out that X is 53. So if this is 90, this has to be 90, so this has to be 90 minus 37. Does that make sense? Now, another one, we're not given any pictures of 90, but we're told that JN is perpendicular to OL. So here's JN, here's OL. So these two are perpendicular. And then I'm also told that OK is perpendicular to OM, which I'm going to do that in a different color. These two are perpendicular. So I have two sets of perpendicular lines. That means this altogether adds up to 90, and then the other ones here will add up to 90. So if we had some other value over here, we could find X with these two values. Or since these two will add up to 90, we'll add those two together. So I have 5x minus 13 plus 3x plus 7 will equal 90. Okay, now this is where that came in, what we were doing in the warm-up. You see how this one's very similar to that last problem? We want to add the 5x and the 3x together first, and the negative 13 and the 7. So negative 13 plus 7 is negative 6. Then we start moving things, so add 6 to both sides. Those will cancel, and I get 8x is equal to 96. Then I divide by 8.